Hi friends, in this video I'm going to talk about fluid mechanics. I'm going to introduce you guys to fluid mechanics. At first, if we hear the word mechanics, what does that mean? No, if we are talking about mechanics, that means we are talking about physics, right? Generally. Other mechanics deal with what with two is divided into two categories. We have the first one to be the kinematics and the second to be the what dynamics. And we are talking about the kinematic aspect. That means we are talking about what the displacement, the distance, and we are talking about the um, dynamic aspect. We are talking about what, the force. Talking about force generally. In short, can just say mechanics is what is the combination of kinematics and also the dynamics. But both kinematics and dynamics, they are the one that brings about the motion of an object. That is the change of position of an object with time. Now looking at this, we have what fluid mechanics. Both of us agree, we know that fluids can either be gas or what or water. It can either be liquid or what or gas. That's what we call fluid. Then fluid mechanics, that is the behavior of these gases and also water, or let's say just these gases and also liquid. Their behavior, the study of their behavior at rest is known as what we call fluid mechanics. Look at the definition, the short definition I'm having here. Fluid mechanics is the study of fluid at rest and also in what in motion. Motion is the change of what change of a position with time, and the study of what of fluids, the study of liquid, gas at rest and also in motion is what we call known as what as fluid mechanics. The study of fluid at rest is known as what is taken to be the surface tension, while the study of fluid in motion, that's where we have what the capillarity. Don't forget that capillarity is what is the rise or fall of liquid. That means rising or falling of liquid. That it shows that the liquid is undergoing change in position, which is what motion. Now look here, we have surface tension. Surface tension is mostly denoted as what as our gamma, or you have it as what your sigma, or you have it as what as T, which indicates tension. So when a fluid is at rest, the surface acts as a strength elastic. That is, the surface will behave as a strength elastic, right? And if you are talking about strength elastic, they are the what? They are the materials that can undergo change in what in their original size. That is, when you strain them, they are going to change what in their original size. A best example of surface tension is just what the behavior of water. Behavior of water when let's say you have a tap water now. If you have a tap water, no, when you close the tap water, there will be a drop of water. That is a drop of water from that tap water. The drop of water is going to behave as if it is at rest. At that time, it's going to stretch like an elastic material. That particular elastic material is known as what is known as the surface tension. That particular strength elasticity of the water is what we call surface tension. Then surface tension is expressed as force per unit area. That is a force that acts on a force per unit length rather. A force that acts on a fluid at a particular length. Force per unit area is what we call what surface tension. Now looking at this, we have units to what Newton meter, because Newton represents the unit of force and meter represents what the unit of length. Then finding the unit, you have what Newton meter. But looking at this diagram, I'm going to use this diagram to explain the molecular explanation of surface tension. That is, I'm going to use this diagram to talk about the molecular explanation of surface tension. Now, at first, what do I mean by molecular explanation of surface tension? That is, when a liquid is at rest, how the molecules behave. How do they behave? Now, as far as surface tension is concerned, look at this now. I'm having what? I'm having molecules, right? All these molecules, this state indicate that all the molecules is at rest, right? They are at rest. But looking at this, these molecules is going to attract with each other. They are going to attract with each other. That is, there is going to be a sign of what of molecular attraction between them. Can you see that? But the molecules at this tip, they are going to act downward. They will act downward. Can you say if they act downward, that is, there will be a relationship between the molecules at the surface and the one at the downward. But the one at this top is going to act downward, while the one at the middle will act with each other. Can you see that? So this kind of what attraction is known as what we call what the surface tension. That is, this is starts from what the attraction starts from this side, and at the top we have what we have some type of attraction. That is, the molecules are attracting themselves. They attract with each other. Look at this. This is coming down. Why this attract with each other? Can you see it down? So this is what we call what molecularity of surface tension. That is the molecular extension of surface tension. All this attraction is what we call tension, which is what surface tension. This surface, the force that is acting downward is what we call what surface tension. So this particular is called what surface tension. This force that acts downward and the force that acts between the water molecules. And take note, this is at rest, not in motion. Now, let's talk about what the factors that can reduce surface tension of a fluid. If we're talking about the factor that can reduce surface tension of a fluid, that means we can just be talking about what the detergent. Yeah, we have soap. If you add what soap to water, it's going to reduce the tension of the water. Okay. Another thing that we have that can reduce the surface tension of fluid is we have increase in temperature, because the more you are increasing the temperature of the temperature is the more the surface tension is going to be reduced. Now, the two factors that can affect surface tension, the first one we have it as what as our that should be detergent. We have it as our detergent, and second one we have to be what to be our increase in what in temperature. These are the two major factors that do affect the surface tension of a fluid. Now, let's check the second case I'm having here. The second case I'm having here, that is what my capillarity. Then have you ever heard, what do you think capillarity can be? If you're talking about capillarity, it's defined as the tendency of a liquid to rise and fall in a capillarity tube. Check it down. That is the tendency of a liquid to rise or fall when placed in a narrow capillarity tube. The rising or fall of this liquid that we are talking about is due to the presence of intermolecular force of attraction between the particles. And if we are talking about the intermolecular force of attraction between particles, that means we'll be talking about the adhesion and also the cohesion. Adhesion and cohesion. I'm going to use these two diagrams to explain what is meant by adhesion and also what is meant by cohesion. In short, both of us are familiar with what we call adhesion. We are talking about adhesion. Adhesion is the force of attraction between molecules of different particles. Or just say adhesion is the force of attraction between molecules of different kind, while cohesion is the force of attraction between molecules of the same kind. For example, the force of attraction between water particles is known as cohesion, while the force of attraction between water particle and also glass particle, that's what we call adhesion. Okay, so just know that the rising of and also falling of a liquid is due to the intermolecular forces present in that liquid. She get that? And the intermolecular forces we have the first one to be adhesion, that is adhesion, and also the second one to be cohesion. Okay, so in short, looking at this diagram, what does this represent? In this case, this is actually my water. This is my water. Okay, this is my water. And this is my This is my mercury. We are going to study the behavior of water in a capillarity tube and the behavior of mercury in a capillarity tube. Looking at the first case I'm having here, look at this. What the particles or the molecules I'm having here is actually molecules of water. And you agree with me that the kind of force of intermolecular force of attraction between molecules of the same kind is what we call adhesion. Between this water to water, we have adhesion force. That is the intermolecular force of attraction between two water particles. The force behind them is known as the adhesion force. But to look at this now, the behavior of this water in a capillarity tube, how does it behave? Immediately water enter this capillarity tube, it rise up to a certain level. Can you see down? This indicates that the water level rises. Can you see that? The water level rises, and on the norms, if you have this kind of meniscus, this kind of meniscus is known as it's called concave meniscus. Sorry, let's just manage it. Okay, This kind of what this is called what the concave meniscus. Why this indicates what the water level, that is the rise of what of the water level. And since there is a rise here, that means there is presence of intermolecular force of attraction. That is the reason why that it is what the water has to rise. Then let's check this second case. This meniscus indicates what a convex meniscus, which indicates that the water, the fluid here doesn't rise, and the fluid here is known as what the mercury. Look at this now very well. If you look at this now, there is this indicates that what the level of the mercury drops. Can you see that the mercury level what drops, which I indicate what arrow to what the arrow of the this arrow indicates that mercury level what drops. And whenever you see a convex meniscus, it shows as what there is a decrease in the level of the particular fluid. Then looking at this very well, why the question is now, why did the fluid here rise and why did the fluid here drops? It is because of the presence of the intermolecular force of attraction. The intermolecular force of attraction between this is due to what? Is due to the adhesion. That is adhesion force. That is the force of attraction between the water molecules and also the capillary tube is adhesion. Because that means, in short, we can just say the adhesion force is greater than the cohesion force. The adhesion force is greater than the cohesion force. The cohesion force is the force that is explained between two water molecules. Why between the glass and also the water? That's what we call adhesion. That means the force of adhesion force is greater than cohesion force. That is the reason why it moves up. But in this case, the adhesion force is lower than the cohesion force. That is, the force of attraction between the mercury molecules is higher than the adhesion force. That is, than the force of attraction between the molecules of different kind. The force of attraction between mercury is known as the cohesion force, right? Or just a cohesion attraction. But if you look at this now, between the capillary tube and also the mercury, there is a drop in mercury level. That means the force of attraction between mercury doesn't appreciate one of the capillary tube, which indicates that the force of attraction between the mercury level, which is known as the cohesion, is greater than the force of attraction between the mercury and also the glass, which is known as adhesion. So here, for a better explanation, adhesion force is greater than cohesion force, while here cohesion force is greater than adhesion force. Then let's quickly move down and check the relationship between surface tension and also the capillarity. Checking the relationship between surface tension and capillarity. If you look at this very well, I have explained what is meant by adhesion and also what is meant by cohesion. Looking at this very well, here I'm having a capillarity tube, right? This is my capillarity tube. If you guys are seeing this like this, okay, let's go like this. This is a capillarity tube. Looking at this capillarity tube, I'm going to use this diagram to show the relationship between the surface tension and also the capillarity. Here, this indicates that there is a rise here. There is a rise of a fluid here. A fluid rises here. And I have my fluid here, right? Yes, I have my fluid here. All these are my fluid, right? There's a rise in fluid. Let me just indicate it with this arrow. Okay, then let's go ahead and bring out the relationship. Now, if there's a rise in fluid here, let's just assume that there's a semicircle here. This is a semicircle, right? And there's another semicircle here. This, in order for these water molecules for this fluid to rise, there must be a contact between the glass capillary tube and also the water molecules. There must be a contact. The contact is going to divide into two. We are going to have one moving in this direction and the other one moving in this direction. So if it's moving in this direction, if the angle of contact moves in this direction, we are going to have one angle here and also the second angle here, because there is an attraction. That is, there is a relationship between the water molecules and also the capillary tube. Can you see that? So the water molecule is going to rise to a certain level, and this you can call, just look at this. This surface is what's known as surface tension. Can you see that? Because it's going to rise to a certain stage and what and rest. The force that is experienced here is known as what? The surface tension. And also, another thing you need to know is also what we also have something we call specific weight or what of, let's say, water, or you say any fluid. This is what is the specific weight, indicates the specific weight of what of this of the fluid. And the fact is that the major relationship between what surface tension and capillarity is the what is the height of the fluid. The height of the fluid is one that indicates the relationship between what the surface tension and the capillarity. The capillarity indicates that the water rises to a certain level while surface tension what takes place. This surface is where we have what the surface tension. Now let's go ahead and use this word to bring out a particular formula, that is to bring out a formula that we can use to solve questions under surface tension and so on capillarity. No, we also have viscosity as well, but I'm going to explain viscosity in a separate video. Looking at this very well, my height will be equal to what? The angle is what is theta, and I have two angles here, which is what? Which is 2 with my surface tension. 2 multiplied by what? By gamma cos what? Cos theta. Can you see that? All divided by what? My specific weight, which is W over what? Over D. Can you see that? So now looking at this very well, it shows as what the height of the water is directly proportional to what? To the angle of the contact, and directly proportional to what? Also to the what? To the surface tension, but inversely proportional to what? To the weight of the fluid. She get down. So now looking at this very well, since I'm having 2 gamma here, there is one angle here, right? There is one at rest here, and there is one at rest at this top. So this will go 2 multiplied by 2 gamma cos what? Cos theta. So I will be having what? I will be having 4 gamma cos what? Cos theta over what? Over WD. Can you see this now? So now let's just look at what I say. Another thing that you guys to take note of is that the angle of what? Of contact for a clean glass is 0. I repeat, the angle of contact for a clean glass is what? Is 0. Okay, why you guys note that the density of water is equal to what? 1000 cm3. I don't need to be telling you guys that. You should know that the density of water is what? Is equal to 1000 cm3. But you should note the fact is that you need to know that the angle of contact for a clean glass is what? Is 0. Now let's just go ahead and finish this formula. You can just recall your weight WD, which is what is known as the specific weight. You can actually express as what? As EG, where my E represents what? Represents the density, which is mass over volume, right? And my G represents what? Represents the acceleration due to what? Due to gravity. You might think that how did this acceleration come into it takes place here? No, we are talking about rise and fall. Rise and fall. Something is rising up and also falling up. There will be what? And there will be an act. As acceleration due to gravity is going to what? To act on it, since it's what? It is free fall gravity. If free fall gravity is going to act on this, is known as what? The acceleration due to gravity. Then substituting everything here, you are going to have your H equals to what? Equals to, that's 2. Okay, let's just take like this. Let's just say it is 4 gamma cos what? Cos theta divided by what? Divided by, look at this, divided by, that's WD. But you can recall for this diameter we have R equals to what? Diameter divided by what? 2, right? Then let's just put it here. You're going to have H equals to what? What you guys are saying that is H equals to what? Equals to, that will be, this 2 is going to what? Is going to divide the one at up, right? So you're going to have 2 gamma plus what? Cos theta divided by what? R E G, right? Where my E is what? Is the density of the fluid, and my G is the acceleration due to gravity. My R is what? Is the radius. My cos theta is the angle of the contact, at the angle in contact, the contact angle. My gamma is the surface tension, right? And this 2 is due to, because we have what? The fact that we have 2 angles here, and also we have what? We have 2 surface tension that is going to be active. If you consider this what? This semicircle, and also the one at the top. Now the final formula is either we use this or we use this, right? We can use this 4 gamma cos theta divided by WD, or use 2 gamma cos theta divided by what? REG, right? Because our specific, this EG represents the value of what? Of specific weight. Specific weight equals what? Equals to EG. right? So that's why I'm having I substitute value here. That's how I'm having what eg, which is w equals to eg. We're having r here. This r represents diameter divided by 2. If you put it there, you're going to have 2 here. That's what? That's 2 gamma cos theta. Or anyway, let me just help you guys to derive it very well for you to know it very well. You're going to have 4 what? 4 gamma cos what? Cos theta divided by what? My w equals to what? That's eg, right? I'll be having egd, right? I'm just calling it it's actually rho, okay? Rho, anyhow I like, you can call it anything you like. So my diameter equals what? Equals to d over 2. Show that I'll be having, this is actually 4 gamma cos what? Cos theta divided by what? That's egd divided by what? 2. Can you see this now? So everything here is actually what? 4 gamma cos what? Cos theta, right? Divided by what? Divided by eg, right? D divided by what? 2. So in this case, I'm having 4 gamma cos what? Cos theta. That's multiplied by what? That's 2 over what? Over EGD. No. That means this should be 2. Yeah, this should be 2. Thank God I proved it. This should be 2. Then going higher, this should be 2, right? So 2 multiplied by 2, that should be what? 4 gamma cos what? Cos theta over what? EGD. That should be the best answer. Then which is equals to what? Which is equals to height. So in short, what you guys to take note of is that the height is one that shows the relationship between what? Between the surface tension and also the what? The capillarity. Because if there is no increase in this height, we are not going to do what? To dictate the surface tension here. Okay?